Hi guys, today in this class I'm going to discuss about this nodal analysis, and already we have seen what are the steps to be followed for analyzing the circuit while you are applying your KCL. So when you apply KCL for a circuit and later if you analyze that circuit, such a sort of analysis is said to be nodal analysis. So first, when you see a circuit, look at the circuit and identify what type of circuit is this. So this is a circuit with independent source. You have only one independent source. If I need to find the current flowing through 8 ohm resistor, 3 ohm resistor and 6 ohm resistor, so how will you find this? So now how many nodes we have? Here we have one node, let it be V1. Here we have another node, let it be V2. So when I write and the equation, this is a third node, this is being the ground node. So what do you write for V1? V1 is equal to 30. Okay, V1 is equal to 30. What about V2? V2 is nothing but, how will you write this equation for V2? V2 minus V1 divided by 8 plus V2 divided by 3 plus V2 divided by 6. Find out your V2. It is asked to find the current flowing through each branch and the corresponding voltages. So how will you do this? So now you can easily rearrange this equation. So it is V1 is 30. Substitute here 30. Okay. Substitute here 30. So you'll be getting V2. You'll be getting V2 by 8 minus. So you'll be getting V2 by 8 minus 30 by 8 and is equal to 0. This is going to be 0. So now this is 1 divided by 8. So you'll be getting 5 by 8 of V2 is equal to 30 by 8. Right. So finally your V2 will be 6. V2 is 6. Now when you go ahead, so V2, this potential is 6. So how will you find this current I2? It is V2 divided by 3. And how will you find this current I3? It is again V2 divided by 6. And how will you find this? It is nothing but, since current flowing is flowing from this side to this side, here to here, so positive to negative or whichever. So this is 6 volt, this is 30 volt. Current will always flow from the higher potential to the lower potential. So it is 30 minus 6 divided by 8. That will be your V1. Okay, what is 30 minus 6? 24 divided by, what is your current? 8. That is your current I1. Okay, this is your I2, this is your, okay, this is your, so this is how we will be finding, and the respective voltages, once you know your current and product of current and the resistance will give you the voltage. Okay, so let us go for the next problem. What I said to you, you need to analyze the circuit. What is the circuit? You have a circuit with the independent as well as dependent source. This is a dependent source. You have a diamond symbol. So dependent source, what source is this? You have an arrowhead. So it is a current source. And it is controlled by what? You have a current parameter. So it is said to be current controlled current source. Okay. So when you look at this, you have only two nodes. This is being the first node and this is being the second node, which is nothing but the ground node. Okay. So when I write KCL for this equation, let it be V1. Okay. So let me take all our outgoing current. This one, everything. So I0 plus outgoing current is positive. I0 by 4 plus Let it be V1. V1 and V0 is same, so let it be V1. V1 by 8. Okay, incoming is negative, but when you bring it to the left hand side, it is 9 amps. Okay, so now what is your I0? How will you write your I0? I0, it is nothing but the current flowing through your 2 ohm resistor. How will you find that I0? I0 is nothing but V0, V0, the same potential, because see here, all are connected to the same nodes. So I can say V0 by 2, which is also equal to V1 by 2. I0 is nothing but V0 by 2, V1 by 2. So how will I write? 9 is equal to I0 is V1 by 2, V1 by 2 plus V1 by 8 plus V1 by 8. Okay. So when you look at this, so 1 divided by 8 is 2 plus 1 by 2 is 0.5. Okay. So which is equivalent to 3 by 4 of V1 is equal to 9, provided V1 is equal to, what is the answer? It is 12. So you have V1 to be 12. If V1 is 12, I0 is 6 amperes. Okay. This is how we will be finding your current at the voltage when you have a dependent source. And what is your V0? V0 is nothing but, what is your V0? V0 is 2I0, which is nothing but V1. V1 is equal to V0. Okay. So let us go for the third problem. So this is your third one. So again, this is a circuit with, first analyze the circuit. This is a circuit with independent source and dependent source. Okay. Let us go ahead with the mesh analysis. So we have seen one problem with nodal analysis. Nodal analysis. One problem in the sense in nodal analysis, we have seen the first category with the independent source alone. The second category with the dependent source and independent source. Now similarly, in mesh analysis, we have seen only circuit with independent sources. Let us see here a circuit with dependent and independent source. Okay, so how many meshes we have? What is a mesh? Mesh is a special part of the loop which does not have any inner loop. So when I assume this, let me take this as I1 and this as I2. Okay, so when I write the equation here, I need to find IP. And see here I have a dependent source. And this is a voltage source. You have a polarity. And this is controlled by the current controlled voltage source. When I write the equation, 24 minus 250 I1. Keep in mind, I1 is equal to IB. See, I1 is equal to IB. Minus 50 into 250 into I1 minus I2 is equal to 0. This is the first equation. This is the first equation. And what about the second equation? Minus of 50 into I2 minus I1 minus 60 IB, which is nothing but I1, because I1 and IB is same, minus 150 I2 is equal to 0. Rearrange this equation, the first equation. So you have 300 I1 and this will be minus 50 I2 is equal to 24. This will be the first equation. What about the second equation? Minus 200 I2 minus 200 I2 minus 50 minus 110 I2 is equal to 0. This will be the second equation. So how will you solve this? How will you solve this? Let me take and solve. So when I solve this, I1 is 0.0164 amps, I2 is equal to minus of 0.11627. Okay, amps. So when we get this, this is B also. So we need to find the IB. So this is how we will be finding the current. And again, if I take a 0.0164, it is 0.016. So it is also equal to 16 milliamperes. Okay. One thing you need to see here is, so whenever you have your resultant current, if it is a negative direction, your assumed current direction is wrong. That is the meaning finally. Okay, so now you have a clockwise assumption, but actually the current flows in the anti-clockwise. That like that we can come to a conclusion. Okay, we can come to a conclusion. All right. Okay, in today's class I have covered three problems, and more problems you can solve only if you have a practice of solving more number of problems. You will come to an idea how to choose a ground node, and how you can solve easily. Okay, you try to solve circuit with dependent sources. Okay. Hmm? So you have one more category of circuits, that is the third category, that is nothing but, see, we have first is circuit with independent sources that we have seen in both nodal and mesh analysis. Next is circuit with independent source and dependent source. Okay, and the third category is super mesh and um, super node. I'll tell you what is that. Okay. Okay. With this, I'll stop today. We'll see more about this next class.